I've taken an EE power bar to bits in a previous video, but that was a different version. This is the E1-06, and this is the one that was subject to the first recall. And latterly they were all recalled. I've noticed the only difference, just looking at them, that I've noticed so far, is that when you press the button twice and the light lights in this one, and then you press it twice again, it immediately starts flashing. With this one, when you press it twice, it lights up. But when you press it twice, there's a sort of pause and then it starts flashing. So the software is definitely different on them. So I wonder if that extends to the circuitry, and there's only one way to find out, and that's to open it up. So this is where I'm going to pause, because I already know from opening this one that it was a lot more, it was quite complex, it was quite heavily glued shut with and I had to actually Dremel the last one open. So I'll be back in a moment. So that was glued just as well as the other one, so it was quite destructive. It seems to be glued in a series of like dots around here. And it did, I had to break it open. The one good thing is I didn't have to Dremel the base open this time, because although there is a double-sided sticky pad in the back of this one, it wasn't actually peeled and stuck. I don't know if that's maybe good or bad. I don't think really, you know, even if it hit the top of this, it can't really short out because it's got this fibre disc on it. I suppose it could stress the little tab if there's any sort of, if the battery was vibrating backwards and forwards inside, but I'm not really sure how close a fit it is. However, the circuit boards of the one that was recalled first before the others were recalled is similar but not identical. They've got roughly the same sort of layout on them, but they've got different component placement, particularly on this side. They've both got the, hold on, I'll bring a picture in. I took a close-up picture. Excuse the fuzziness, it was hard getting a really good, close, reliable picture. So it's got this chip that is anonymous. I'm not 100% sure what that chip is at all. I thought it might be a standard power bank chip called an AP5901, but I'm not 100% sure its pinouts are identical. It seems to be slightly different. Also, well, the main features here is that it does have a DW01B, which is the cell protection chip, and on the other side of the circuit board it's got the dual MOSFET pair that are coupled over to that chip, so that in the event of over discharge or overcharge, this chip can kick in. This will also detect short circuit conditions. The drive for the chip, for the actual booster, it appears, as far as I can see, to be this. Now, this one is marked an EL448. The other one was marked differently. Hold on a second, just to remind myself. So this is the other one. EL548. So that's EL548 in this one, EL448. I'm not 100% sure what those are. I couldn't easily find them online. On the other side, we've got the only other things worth noting are that this component, XORB, not 100% sure, looks like a big transistor. I'm not sure if it's, I'm not 100% sure what that's for. It's coupled, seems to be coupled to a large R050 resistor, a fairly high current resistor. I don't know if it's for detecting short circuits, further protection, I'm not 100% sure. But then there's a small transistor, I'm guessing that's what that's for, under here just to turn this LED on. The charge control chip is exactly the same sort of thing you'd find on these little charge circuit boards for these. You get these little modules on eBay that let you plug in mini or micro USB, and it charges a lithium cell, and it just stops at the threshold, shows when it's charging, stops when it's charged. And in the case of this one, it's a 4057A. I think it was a 4056 on this one. Let's just double check. TP4056, which is the more common type. Not 100% sure what the difference is with the 4057, I should have checked that up. But fundamentally, you know, again, I'm not sure what brand the lithium cell is. It says TS 18650 2600, which I assume is the capacity, 3.7 volt, 0508, I'm guessing is the manufacturing date. I tested it, I charged it through one of my little monitoring devices, and it came at 2400 milliamp hour from flat to charge. So that's close enough. I'm not really sure. I mean, again, it looks a modestly sensible circuitry. They've got the silicon sleeve and the sort of cable coming up the side. It's got that rubbery, silicony feel. The inductors are slightly different. The one in this one is a 3R3 versus 4R7. I'm guessing that that's 4.7 microhenry and 3.3 microhenry, respectively. Fundamentally, I mean, relatively speaking, compared to the little cheapy USB power banks you can buy off eBay, the sort of generic ones with no major protection, these ones do actually seem to make an effort at some protection. And I did, when I fully charged this one, I then discharged it completely by using it to charge my Cubit H1 phone. And the Cubit H1 phone will just sneak the current up if it can to deliberately just maximise how much current it can get to charge it. I think it uses that system whereby it nudges the current up a bit and sees if the voltage drops. If it drops too much, it will nudge the current back down a step. It just it's designed for fast charging. And I have to say, leaving it on the full discharge cycle, it didn't get excessively hot. So that's a bit inconclusive, isn't it? I mean, it just, without actually removing all the components, which should be a bit of a nightmare because it's all surface mount, and then tracing all the tracks, and certainly without knowing what this chip is, it just makes that a wee bit harder to ascertain if they've made a mistake in the design, which I don't think they'll have done. It would have been nicer if they'd, I wonder if the cells maybe were the weakest point, maybe it was just bad cells, I'm not 100% sure. Maybe if they'd chosen a higher brand, I'm not sure what make these are. So again, you know, it's different circuitry, but it looks fine. It doesn't look like a bad design. It looks like they've made an effort to make these quite bomb-proof, so to speak. So I'm guessing the ones that went in fire probably were just a random incident. You know, it was just the rogue product. I mean, even iPads and things swell up and go on fire in the past, and Apple computers, just about anything. It doesn't matter how high profile the brand is, you're going to get the odd rogue incident that, you know, a lithium battery fails dramatically. So I'm wondering if that's what's happened here. Certainly the ones that did burst into flames, it looked like the lithium battery had failed in some way. But yeah, it's hard to say. I don't see anything majorly wrong with this design. It looks fairly sensible. So yes, I don't see the weakness. I don't see why these failed. It's a shame because, again, they seem quite good. So I've given this a full charge and then I've left it on charge for a good length of time, and the voltage went up to 4.2 volts as you'd expect for a charge, and then it's just cut off the charging and it's just settled down and is hovering around about the 4.1 volt mark, and it's just sort of sitting there. So again, it's not overcharging, it's not undercharging, it's the same as the previous cell, so that doesn't give any clues as to why they had an issue, and it might just be that it was just rogue batteries or rogue packs or abuse, so who knows. It's a shame. It seems like they have been quite well thought out. So yes, that's the, what model was that? That was the E1-06. The one that started the initial recall. So yes, inconclusive, I'm afraid. It seems pretty good.